Hey class, in this video we're going to start taking a look at engines. If you can understand how a small gas engine works, you'll be able to understand how the engine in your car works. Let's take a look. By the end of the lesson, I want you to identify some key terms of engines, identify the major components of an internal combustion engine, and to describe each stroke of a four-stroke engine. On your slide, we have a cross-section of a small gas engine, maybe one that you'd find in a lawnmower. This is a one-cylinder engine that's a four-stroke engine and uses overhead valves. That should all make sense by the end of the video. So what are small gas engines and what are some uses for small gas engines? Do you know some examples of small gas engines that you've used? Well, here's a number of examples of small gas engines: chainsaws, weed whackers, snow blowers, lawnmowers, mopeds. All these have small gas engines that are smaller than the ones that you'd find inside your car, engines that are fairly easy to work on. To understand how small gas engines work, we need to understand internal combustion. A cannon is also an example of internal combustion. To fire a cannon, a small amount of fuel or gunpowder is placed deep down inside the cannon. When the gunpowder is ignited, usually with a flame and a wick, an explosion happens, and that explosion fires a cannonball out of the cannon. That explosion happens inside the cannon, and so it's internal combustion in a small enclosed space. And because it happens inside that small enclosed space, high amount of energy is exited out of the cannon. So you can understand how a cannon works, you might be able to understand and relate that to how a small gas engine works. Now, we don't use gunpowder and cannonballs inside engines. That'd be bad, that'd be dangerous. What we do use is we use fuel. Many times we use gasoline. And so in order for that gasoline to work inside our engine, we have to mix that gasoline with air. By giving the gasoline more area to work with, it becomes more effective. So we're talking about combustion. Combustion is where we have an air-fuel mixture, is ignited, and is burned inside an engine. Now, how do we create an air-fuel mixture that can be combusted? Well, we do that in small gas engines using a carburetor. Inside cars, we use fuel injectors. So let's take a look at how that air-fuel mixture is created. So to create an air-fuel mixture that the engine can use, we have to break up that fuel into small droplets and mix that with air. And by breaking up gasoline into tiny droplets and mixing it with air, that process is called atomization. Some examples of atomization are spray paint cans, perfume bottles, cologne bottles. Any type of spray that you go ahead and spray out, that is an atomization process. The way they thought of this way back when they were inventing cars was by old-fashioned perfume bottles. Here's an old-fashioned perfume bottle up on your slide. By pressing on this little bulb here, you force air across this little tube, and by forcing air at a high speed across this tube, the high-speed air grabs on the perfume and then causes an air-perfume mixture that you then spray on yourself. Spray paint cans work the same way, perfume bottles work the same way, lighters work in a similar way. You're forcing high pressure air, and that change in pressure attracts some of that fuel or perfume or whatever it is. That's the atomization process. So if you use this atomization process for fuel, by creating a cloud of air and fuel, a mist, when you ignite it, that creates a sudden release of heat energy. And that is what small gas engines do using a carburetor. Now, our modern day car engines use fuel injectors, but we're going to stick with just talking about carburetors for right now. So small gas engines don't have perfume bottles or spray paint cans. What they do have is that what are called carburetors. So what is a carburetor? Well, here's a cross-section of a carburetor that you might find on a lawnmower. The air moves inside the carburetor. As the air moves inside the carburetor, it gets to this little choke point. All right, the choke point causes a change in pressure, and that change in pressure attracts little droplets of fuel into the airstream. Now my airstream now has both air and fuel mixed inside of it, and that air-fuel mixture will now go into the combustion chamber that can be then ignited and create the energy needed to move the piston up and down and to do the next process, which is what we're going to talk about. So this is a little bit about how that atomization process works of taking fuel, mixing with the air to create the right mixture that we need to get the engine to move. So there's a couple different engine types. We have what are called two-stroke engines and four-stroke engines. Do you know some of the differences between the two? So two-stroke engines have a gas and oil mix. All right, you might have a small can inside your shed with a fuel oil mix. All right, two-stroke engines are usually a lot smaller. In this case, you have a weed whacker and a chainsaw. They're usually pretty light, and they're usually less expensive. Their negative is that they are super, super loud. So make sure you wear earplugs. What's nice about two-stroke engines is that they don't have, you can turn them any which way. The air and the gas and oil is mixed, so they lubricate themselves pretty well. But they do have some drawbacks. One of the drawbacks is being very loud. Now, a four-stroke engine, you can tell the difference because the gas and oil is not mixed. Just like in your engine for your car, you don't mix the oil and gas. So a four-stroke engine, the gas and oil is not mixed. Usually they run considerably cooler in temperature. They usually have a larger engine, and they're usually pretty quiet. Now, here is a snowblower, and here is a lawnmower. So again, how can you tell the difference between the two? Usually it's by size, but most definitely whether or not you're mixing the oil and gas together. Next, we're going to talk about what do I mean by stroke, four-stroke and two-stroke. When I'm talking about stroke, I'm talking about the movement of a piston. Both a four-stroke engine and a two-stroke engine have a piston, and that piston moves up and down. The piston moves from either top dead center to bottom dead center. And that movement from top to bottom is a stroke, and the movement from bottom to top is another stroke. Here in my four-stroke engine, we have top dead center here and bottom dead center here. And again, the movement of the piston from bottom to top is a stroke, and from top to bottom is a stroke. So what do these strokes mean? Well, it takes two strokes for a two-stroke engine to complete its whole cycle, and for a four-stroke engine, it takes four strokes to complete the whole cycle. What do I mean by a cycle? Let's take a look at that next. On this screen are the four strokes of a four-stroke engine cycle. Remember, a stroke is when the piston moves from either bottom dead center to top dead center, or top dead center to bottom dead center. So let's take a look at the four strokes. The first stroke is called intake, where the air-fuel mixture comes into the combustion chamber. The next step is compression. The piston now moves up, and as the piston moves up, it is now compressing the air-fuel mixture in the compression chamber. The third stroke is combustion. Right before the piston gets to top dead center, the spark plug will ignite the air-fuel mixture. The air-fuel mixture has gotten really, really compressed and under really high amounts of stress and energy. That explosion now pushes that piston down to bottom dead center. And then the fourth stroke is exhaust, and the piston will then move back up and force the burnt air-fuel mixture out of the combustion chamber. So these are the four strokes of the four-stroke cycle: intake, compression, combustion, and exhaust. A four-stroke engine needs four strokes to complete this process, while a two-stroke engine just needs two strokes to complete this process. Let's take a look at the process in a little bit more detail. For this process to work, the different parts of a small gas engine all have to work together. So here's an example of one of the many types of small gas engines that you might find. This is an overhead valve engine. So let's take a look at some parts. Well, one of the most important parts is the piston. All right, so the piston is what is moving up and down, compressing that air-fuel mixture. As the piston moves up and down, the piston is connected to a connecting rod, and that connecting rod is connected to a crankshaft. That crankshaft has a flywheel on it that helps give it some more weight, and that crankshaft is then connected to your lawnmower blade, connected to the front end of your snowblower. In a car, this is then connected to your transmission. All right, so the piston is moving up and down. In order for the piston to move up and down, it's got to move up and down inside the cylinder block. All right, and the cylinder block has been machined out to give a nice, smooth movement of that piston. And that piston usually has rings around it too, and those rings rub up and down the side of the cylinder block, and there's oil in there to prevent too much friction. Too much friction would be bad. All right, another thing that's important are what is called the intake valves. There's two valves. You have an intake valve. The intake valve open and closes. When that open and closes, it allows the air-fuel mixture to be intaked in the combustion chamber. You also have an exhaust valve. The exhaust valve opens and closes, allows the burnt air-fuel mixture to move out to the muffler to be exhausted. The exhaust valve is a little bit stronger, a little more heat resistant than the intake valve, because the exhaust valve has to open up and allow that very hot air-fuel mixture to be exhausted. Another important part is your spark plug. All right, your spark plug has a little tip which will be create a spark that will ignite that air-fuel mixture. The other thing that you will have is you have these things called a cam. What is a cam? Well, a cam moves, and as it moves, it causes the valves to open and close at the right time. Timing is super important for all these parts to work together. Another thing that's important to know is your crankcase. And your crankcase is probably going to have some oil in it, because as your piston is moving up and down, oil is then splashed in all the little parts inside the cylinder block to make sure all the parts are well lubricated. So there's a lot of parts here that are moving up and down, but it's important to understand some of these parts as we take a look and then break down the 4 strokes of the 4-stroke engine. Let's move on. So the first stroke of a 4-stroke engine is intake. The piston is moving from top dead center to bottom dead center in this stroke. As the piston is moving down, it creates a vacuum, and because the intake valve cylinder opens, air-fuel mixture created by the carburetor or the fuel injector is now moving inside the combustion chamber of the engine. As the piston moves down, this whole combustion chamber is filled with the correct amount of air and fuel that will then be burned. So again, this is the first stroke of the 4-stroke process, and it's called intake. The second stroke of the 4-stroke engine process is called compression. In this instance, the piston is moving from bottom dead center to top dead center. As the piston is moving up, it is now compressing that air-fuel mixture into a very small area. By compressing that air-fuel mixture into a small area, it is generating a little bit of heat, and it's getting ready to get burned up. In this stage, all the valves are closed, and right before the piston gets to top dead center, our next stroke of the 4-stroke process is going to happen. The third stroke of the 4-stroke engine process is the combustion or the power stroke. Both pistons are closed, and right before the piston moves to top dead center, the spark plug ignites. And as the spark plug ignites, that air-fuel mixture combusts. And as it combusts, it forces the piston down. And by forcing the piston down, you now have movement in the crankshaft and the flywheel, and this is where you get the power from the engine. The last stroke of the 4-stroke engine process is exhaust. Once the air-fuel mixture has been combusted, we now have to get that burnt up air-fuel mixture out of the combustion chamber. So the exhaust valve opens. As the exhaust valve opens, the burnt air-fuel mixture is then ejected out of the combustion chamber and then moves on to the exhaust manifold and the muffler. The piston moves back up to top dead center, and the heat is moved fairly quickly. So those are the 4 steps of the 4-stroke engine process. So here are the 4 strokes again, side by side. Just to review, For our intake, which is our first stroke, the air-fuel mixture comes through the carburetor or the fuel injector through the intake valve into the combustion chamber, and the piston is moving down to bottom dead center. For compression, the piston is moving up to top dead center. As it is compressing that air-fuel mixture. Right before the piston gets to top dead center, our spark plug ignites. As our spark plug ignites, it burns that heated air-fuel mixture, sending the piston down to bottom dead center. As the piston comes down to bottom dead center, it then moves up to top dead center for our last and exhaust stroke, and it pushes that burnt up air-fuel mixture out of the exhaust valve and out into the muffler and combustion chamber. Once the exhaust stroke is done, we then repeat the process all over again. That piston will then move down, the intake valve will open, and we repeat over and over and over again. To give you an idea of how fast this process works, if you can imagine, the intake and compression is one rotation of the crankshaft, and the combustion and exhaust is another rotation of a crankshaft. Now, you might see RPMs on the engine of your car, which is rotations per minute. Well, if this is one rotation and this is the second rotation, I want you to know that the average lawnmower does about 3,000 RPMs, or rotation per minute, as you push your lawnmower around, which means that you have these two rotations moving at a very fast rate per minute. It's pretty impressive. So hopefully you understand a little bit of how the four-stroke engine process works. Now, there's a lot of things to consider, and there's a lot of things that could be said about this process, but three things that I think that are important to know. First one is what's called valve timing. Can you think why valve timing would be important? Well, don't forget, the intake valve and the exhaust valve have to open and close at the exact right time for that intake air-fuel mixture and the exhausted air-fuel mixture to move throughout the engine. So having those valves open and close at the right time is important. The other thing is we want to make sure that piston doesn't hit the valves when it moves up to top dead center. So valve timing is super important, and it's usually controlled by these little camshafts. Another important thing to consider is lubrication. Why is lubrication important for an engine? Well, the engine is lubricated in many different ways. One is called a splash system, where there's a little attachment to the crankshaft, which causes oil to move all inside the chamber. All right. Sometimes there's a pump system, and the fact that oil weight breaks down and you've got to change the oil. Oil is super important to make sure the engine runs a long time. And the other thing for a four-stroke engine, which you don't have to worry about with a two-stroke engine, is the fact the engine has to be upright. Lawnmowers and snowblowers that are four-stroke don't work very well upside down. They need to be right side up in order for the engine lubrication to work. So those are just three of the things that are important to consider when you're considering and working with small gas engines. So in this video, we took a look at some examples of two-stroke and four-stroke engines. We identified some of the basic parts of two-stroke and four-stroke engines, and we identified the four strokes of the four-stroke engine process. Do you remember what the four strokes were? What are some questions or concepts you have about four-stroke engines or engines in general? Thanks for watching.